number of the nuclear reactions actively working in the stars to produce a huge amount of energy. What kind of reaction is expected? Hydrogen nucleus is H. Sometimes we could use a P to describe the hydrogen nucleus because it is protons. Hydrogen nucleus has the lowest charge. Charge is 1. This is lowest charge proton has among all the nucleides. Lowest Coulomb barriers for protons due to the lowest charge. This lowest charge produces the lowest Coulomb barriers, make it possible for a proton to approach another proton in the lowest temperatures. Two protons are expected to react at the lowest temperatures. Two protons react to form a deuteriums by converting the protons to neutrons. So in the first step, protons plus protons actually react to form deuteriums. So in this case, one of the protons is converted to the neutrons, emitted positrons, plus electron neutrinos. So maybe it's better to explain a little bit about the positrons. E plus is a positron. A positron is an antiparticle. This is antiparticle. And has the same characteristic with the electrons, except the opposite charge. This positron has a very similar characteristic with the electrons. But the electron has a negative charge. Positron has a positive charge. This is a difference. And the same mass. Actually, positron was discovered by Anderson in 1932, and he was awarded the Nobel Prize in 1936. So in the first steps, proton react with another proton to produce the deuteriums and the positrons and the electroneutrinos. But we need a more step to produce the heliums. Deuteriums react with the protons to form the helium-3s. So in the next steps, after deuteriums react with another protons to form the helium-3. So gamma ray is emitted in these reactions. Helium-3 is a light isotope of the helium-4. So helium-4 is a stable element. So we need to form the helium-4s. Helium-4 is finally formed by the reaction of the two helium-3s. So helium-3 plus helium-3 to form the helium-4 plus 2 protons, emitted 2 protons. More heavy nucleides, sometimes lithiums, beryllium, or boron, are involved in the nuclear reaction to form the helium-4 nucleus with an increase in the temperatures as a catalysis, because the proton is difficult to approach the nucleus. These has a larger charge. it's quite difficult for a proton to approach this object. So we have to increase the temperature. But these nucleus are actively working as a catalysis. Maybe it's better to write down all the equation at first. So proton react with another proton to form deuteriums plus positron plus electron neutrino. And the deuteriums react with another proton to form the helium-3 emitted gamma ray. And helium-3 react with the helium-3 to form the helium-4 plus 2 protons. So we'd like to combine these three equations. So at first we have to look at the final product, helium-4. Then we'd like to remove these helium-3s. Helium-3 can be found only the second equation. Then we have to multiply it twice, the both sides of the equations. Then helium-3, this helium-3 can be removed by summing up these two equations. But in this case, we have another problem. We have two deuteriums. Then we'd like to remove these two deuteriums and then find out the first equations. We have one deuterium. Again, we have used the same method to multiply the twice in the first equation. Okay, then we can sum up these three equations. Then helium-3 is going to be cancelled out. The deuterium is cancelled out. Then 2 proton is cancelled out. So this means final result becomes 4 proton converted 1 helium-4 plus 2 positron plus 2 electron neutrino. Okay, this is the answer to this practice.